Assalamualaikum sir, I am Amina Akhtar and my registration number is 20222310116. I am going to present the utility maximization problem, Walrasian demand and properties of Walrasian demand. Firstly, I am going to talk about utility maximization problem, which defines as consumer maximizes her utility level by selecting a bundle X where X can be a vector subject to his budget constraint, which mathematically takes the form of max u of x greater equal than 0 subject to p dot x less equal than w, in which w is the wealth level. Then the existence of it can be recognized by if p greater than 0 and w greater than 0, that is bpw is closed and bounded, and if u dot is continuous, then there exists at least one solution to the utility maximization problem. If in addition preferences are strictly convex, then the solution to the utility maximization problem is unique. We denote the solution of utility maximization problem as the argmax of the utility maximization problem. The argument x solves the optimization problem and we denote it as xpw. Then I am going to demonstrate a theorem related to utility maximization problem, which is Weierstrass theorem. It states that for optimization problems defined on the rails, if the objective function is continuous and constraints define a closed and bounded set, then the solution to such optimization problem exists. Moving to the next slide, our next topic is Walrasian demand correspondence, which states that XPW is the Walrasian demand correspondence, which specifies a demand of every good in R positive for every possible price vector P and every possible wealth level W. Here I have given a graph indicating it, in which we can see that there are 4 bundles and 3 indifference curves depicted as U1, U2 and U3, in which Walrasian demand XPW at bundle A is optimal, as the consumer reaches a utility level of U2 by exhausting all her wealth. But bundles B and C are not optimal, despite exhausting the consumer's wealth. They yield a lower utility level U1 where U1 less than U2. Then bundle D is unaffordable and hence it cannot be the argmax of the utility maximization problem given a wealth level of W. Then I would like to switch to the properties of Walrasian demand. If the utility function is continuous and preferences satisfy LNS over the consumption set X is equal to R4, then the Walrasian demand XPW satisfies the following properties, of which the first one is homogeneity of degree 0. It states that XPW is equal to X alpha P alpha W for all PW and for all alpha greater than 0. That is, the budget set is unchanged. It can also be said that if P dot X less equal than W, then it is also true that alpha P dot X less equal than alpha W. We do not need any assumption on the preference relation to show this. We only rely on the budget set being unaffected. Here, to prove this statement, a graph is also given, in which we can see that on the budget line of x1 and x2 and the indifference curve, in a particular point XPW is unaffected. The second property is Walras law. It states that P dot X is equal to W for all X is equal to XPW. It follows from L and S, if the consumer selects a Walrasian demand X belongs to XPW where P dot X less than W, then it means we can still find other bundle Y which is epsilon close to X where consumer can improve his utility level. If the bundle the consumer chooses lies on the budget line, that is P dot X prime is equal to W, we could then identify bundles that are strictly preferred to X primes, but those bundles would be unaffordable to the consumer. Here on the graph we can see that here is a particular point y of y and x, and also a particular point of y and x prime on the budget line, which depicts the fact that identifying bundles that are strictly preferred to X primes but those bundles are unaffordable. It can also be stated that for all X belongs to XPW, there is a bundle Y epsilon close to X such that Y greater than X, then X does not belong to XPW. The last property is convexity or uniqueness. In this, it states that if the preferences are convex, then the Walrasian demand correspondence XPW defines a convex set, that is, a continuum of bundles are utility maximizing. If the preferences are strictly convex, then the Walrasian demand correspondence XPW contains a single element. It is also shown in the two graphs in which strictly convex preferences is shown at a particular point and hence XPW is unique. That's all for my presentation. Thank you for watching, sir.